We're going to work through another example of using the Gauss-Jordan method in this video. But before we do that, I want to remind you what our goal is, how we start, and how we want to end up. Here we have a system of three unknowns, and we have three equations that relate those three unknowns. So our first step is to make sure that we have our x's in a column, our y's in a column, our z's in a column, and then our constants, remember, need to be on the right side of the equal sign. So if it's not set up that way, then you need to make changes at this point. Once it's set up in this format, then you're ready to write your augmented matrix, which is this step right here. You're stripping away the variables until you're only writing the coefficients in each of the columns and then your constants in the last column. Remember, if there's not a number in front of the variable, then it's assumed to be 1. So the coefficient there is 1, the coefficient here is -1. So make sure you take the sign with the number, the plus or the minus sign with the number. So we're going to perform row operations on this matrix so that we get to our solutions matrix, which is shown down here, and it has ones on the diagonal, zeros everywhere else, and the final column over here represents our ordered triple where x is 1, y is 2, and z is -1. So these ones on the diagonal here represent simplifying this first row for x equals a number, the second row for y equals a number, and the third row for z equals a number. If you had more variables, more equations, you would have a larger augmented matrix, but you would still be looking for that particular pattern. Now, sometimes on problems, they're right up front and they tell you to use the Gauss-Jordan method to solve. But sometimes they word it a little bit differently. Sometimes they tell you to solve using Gaussian elimination. That's the same thing. Sometimes they tell you to use row operations to solve the system. Again, that's the same thing. So let's solve this system using Gaussian elimination, using row operations, in other words, using the Gauss-Jordan method. The first thing that probably we want to do is, well, first of all, we need to make sure that our x's, y's, and z's are in a column, and that the constants are on the right side of the equal sign, and they are. So this is set up and ready for us to write our augmented matrix. So we're pulling those numbers away from the letters. And then our constants are on the other side. Remember that sometimes you see the augmented matrix in textbooks with the vertical line drawn right there, which represents the equal sign. That's not required when you write it, and it certainly does not show up on the calculator. So we're going to go to the calculator and enter this augmented matrix. In your calculator, you want to start a calculator page, probably be in a new document just to make sure everything is nice and clean, and then you want a calculator page. The easiest way to create a matrix is to use this button to the right of the 9, and since you want to set your own size of matrix, then you want this one that's highlighted. Just move your arrow keys if you're not already highlighting that selection, and then press enter. This allows us to set our number of rows, which should be 3. So I'm pressing tab to set the number of columns, and the number of columns will be 4. This gives me a template for entering those numbers on the augmented matrix. Now, once that's entered, I'm trying, remember, to set up that pattern where I have ones on this diagonal and zeros everywhere else. Since I already have a 1 in this first position, then that's like a bonus. That's a gift. I don't need to change anything. I need to go to the second position, and I need to set a 0. The first thing you want to do in a column is set a 1, and that should be in that first position. Now, to get a 0, I need to use 2 steps. So we're going to press the catalog button right here, and if you've been using matrices, then you're going to come up to these 2 options right here. Multiply, row, and add is our 2 options, so we're going to enter there. And we want to multiply the row that has the 1 in it by a number that when I add it to this number will give me a 0. So to get 0 from 4, I need a -4. So that's what I'm going to multiply by. Then I want to arrow up and choose that matrix. So press enter, then comma, and I want to multiply by row 1, and I want to change row 2. When you do that, you see I still have the 1 in the first position. I have a 0 on the second row, first column. Now I want a 0 on the third row, first column. So I'm going to do the same thing. A 0 requires 2 steps, so I go back to the catalog, mrow add, and I need to ask myself, what am I going to add to 1 to make that a 0? I'm going to add a -1. So that means I'm multiplying this row that has a 1 in it by -1, then comma, up arrow to select your matrix. I'm multiplying row 1, I'm changing row 3. Always end with the number of the row that you're trying to change. Now you can see that I have a 1 in the first row, first column, and 0s in the rest of that column. And I'm ready to move to the next column. When I go to the next column, I want to place the 1 first. I want a 1 to be diagonal from this 1. So where there's a -5, I want to place a 1. Placing a 1 requires 1 step. So when I go to my catalog, I want to choose multiply row. And I only want to change row 2. And I just need that multiplication step to do it. So I need to multiply -5 by a number that's going to leave me a 1 right there. If I multiply by -1/5, because I want a +1, then that will get that for me. Select my matrix. I'm changing row 2. If it's a single operation, I'm just going to have a single row that's affected at the end. Now notice my first column didn't change, and now I have 1s on the diagonal of the first 2 columns. Now that I have that 1 placed in this column, I can go to these other 2 spots and put 0s, make the 0s happen. So I need a 0 where this 1 is. A 0 requires 2 steps. So I go to the catalog, I choose mrow add, which are my 2 steps. I need to add a -1 to 1 to get that 0. So I'm going to multiply row 2, which is where my 1 is. I'm going to multiply it by -1. Go up and select my matrix. I'm multiplying row 2, and I'm changing row 1. Now, if you ever make a mistake, because this does get confusing, if you ever make a mistake, then you just need to go back to your last correct matrix. I know this matrix is correct because I have 1s on the diagonal. I still have the 0s everywhere that I've placed them. So this is a good result to have. Now I'm going to make a mistake. I'm going to show you a mistake on the next one, just so you can see how you can recover from that without having to start at the very beginning. So I want a 0 right here, where the -4 is. I know that a 0 is going to require 2 steps, so I'm going to do mrow add. And I want to have, like I said, a 0 there. So let's say that I multiply by 1/4 instead of what I should multiply by. So I put in my 1/4, I go up and grab my matrix, and then I'll say (2), (3). So I'm changing row 3, I'm multiplying row 2, and I'm changing row 3. I did not get the results that I was looking for because I wanted a 0 here and it didn't happen. So let's throw this matrix out. We're not going to write it down. We're not going to write that step down. Let's go back here and pick up our last correct result, which was this one right here. You just select it, press enter on it, and now you're back to that situation without having to go all the way back to the beginning. I still have my 0s here in all these selected places, and I have the 1s on the diagonal, and my numbers look pretty good. So let's think about this a little bit. I need the 2 steps for the 0, and I need to know, what am I going to add to the -4 to get a 0? I need to add 4. So I'm going to multiply row 2 by 4 to get that 4 in that position. And I select my matrix. I'm multiplying row 2 by 4, and I'm changing row 3. Always end with the row that you're changing. Now you see my 1s on the diagonal, 0s there, so everything's looking good. And actually, this looks pretty good right here. I already have a 0 in that position. But when I go to the third column, the first thing I want to do is place the 1 in the correct place. And it needs to be diagonal from those ones that I have. A -1 is not good enough. I need to make sure that that's a 1. There's one step for a 1, so we're going to use M row. And we just want to multiply this row, or this number right here, by -1, because -1 times -1 is +1. Go up and select your matrix, and then we're only changing row 3. We're only using row 3, and we're changing row 3, so you only have that one number after your matrix. Notice I have 1s on the diagonal, 0s everywhere except for where this -1 is. So I need to put a 0 there. That requires 2 steps. M row add. I need to add a 1 to -1 to get 0. So I'm going to multiply row 3, which is where my 1 is. I'm going to multiply row 3 by -1. Oops, sorry. I'm going to multiply it by 1. Go up and pick up my matrix, and then comma 3, and changing row 2. Easy to get distracted here. So I have 1s on the diagonal, 0s everywhere else, and then these numbers that are in the far right column are the answer to my system. This takes some practice and some patience, working through some mistakes that you make, but I'm sure that you'll get it. So when I go back to my problem and I fill in the answers over here, they have given me this solution set as an ordered triple. So I just substitute in my -2 right here, and then 13, and then 20.